Okay, so heating curve. Heating curve or cooling curve. When you go towards the right, it is heating curve. If you are going towards the left, that is cooling curve. Okay. So, on x-axis, we are recording the time we started heating, and y-axis is temperature in degrees Celsius. That's what we measured last time. Okay. So, on this graph, I gave you ice, which is at what temperature? Minus 46 degrees Celsius. So you got ice which is very cold, minus 46 degrees Celsius, and you can write ice is in what state? Solid, or you write ice if you want to write. So when you heat the ice, the temperature is increasing until it reaches 0 degrees Celsius. So the 0 degrees Celsius is called the melting point of ice, or it is also the freezing point. So when you heat, temperature increases. When it reaches 0 degrees Celsius, you can see the line is a horizontal line. It is not increasing the temperature. The reason for that, because whatever heat you are providing is used for doing what? Melting the ice. Because 0 degrees Celsius is a place where all solid ice will convert into what? Liquid. So now here in this line, that is also 0 degrees Celsius, but you have water there, water. Okay, again, then you will see again there is an increasing temperature. Water from 0 degrees Celsius, it will increase when you heat until the temperature reaches what? 100 degrees Celsius. That 100 degrees Celsius is called what? Boiling point of water, or more scientifically we can say that is the vaporization point. So this is water at 0 degrees Celsius that will convert into what? Gas. What is the name of the gas of water? Steam. Okay. So the liquid water will convert into gas. If you want to know the name, write water to water vapor. That is called steam. And that process, this line is called boiling, or more scientifically you can say that is called what? Vaporization. Okay. So now you have here in this line, you have steam at 100 degrees Celsius. So you have steam here at 100 degrees Celsius. Again, you will see a temperature change, and we are stopping here at 137 degrees Celsius. So temperature will keep on increasing if you are providing more heat. Okay. So this is how heating curve looks like. If you are cooling from the steam, okay, that will be the opposite. What will be the opposite of vaporization called? Condensation. Just include that terminology there. Sometimes you need that. When you cool a steam, it will convert from gas to liquid. That is called condensation. And same thing, when you go here, going backward is called what? Freezing, or we can also scientifically call fusion. Fusion and freezing are same thing. It is converting liquid water into solid ice. Combining, they will form fuse together, that they will form ice. Okay, so now we are going to answer a few questions on there. Okay, so you can see it is labeled A, B, C, D, E. Where is the biggest increase in kinetic energy happening? C. Okay, because that line is longer, right? And we know that if it is a slanted line, temperature is increasing. So I'm going to write this line. There is a change in kinetic energy, and that is a longer line. This is also, there is change in kinetic energy, and A is also having change in kinetic energy, because all of this having change in kinetic energy because of increase in temperature. Why that line is longer? A is shorter, and then the last one we don't have the complete graph. Why line C is longer? Why water is taking longer to reach boiling point? We already learned the reason. Because of high specific heat of water. Very good. So go ahead and write because of high specific heat. Where is the biggest increase in potential energy happening? D. So potential energy, yes, potential energy is happening in straight lines, even though there is no temperature change, but we know that there is heat still being absorbed. That is converting into what? Yeah, potential energy. So I'm going to write this line, there is a change in potential energy, and this line also change in potential energy. What is happening in that session? Why D is longer than B?
Because the water is boiling.
Water is boiling, that's right. In B, water is melting. Okay, both are water. Why? Liquid water to steam takes longer than solid ice to liquid water. We know the reason. We already learned the reason. It is, yes, it is one of the property of water, one of the amazing properties of water. What is that? Because there is hydrogen bonding. Breaking of hydrogen bonds is happening there. So actually there is vaporization. Usually solids will have. Good afternoon, Mrs.Marykutty. She's absent today. Yeah. Okay. Thank you. Bye. Okay, so now just scaffold everything we are going to write. You can write by yourself. You need help. I can write it. First one, line A. Line A, we know that there is solid. Since it is an example of water, you can write that is ice, right? Yes. Yep. So here there is change in delta, change in kinetic energy. Okay. Then you can write there is increase in temperature. That's why kinetic energy is increasing. Increasing temperature until what? Until 0 degrees Celsius. That is the what? Melting point. Okay. Then line B. Line B, we know that it is a mixture of what and what? There will be little bit of solid and there will be liquid. There is potential energy is changing. And there is a phase change, right? Solid is converting into what? Liquid. That is called what? Melting. And what is constant there? temperature or kinetic energy is constant. Okay, now write the rest. You can do it. You don't need my help. Okay, so line C. Line C. Line C is liquid water, right? And you can see there is a slanted line, so change in what happens? Kinetic energy, and temperature is increases until what? Until it boils, that is 100 degrees Celsius. Until it reaches boiling point. Okay, line D. Line D actually containing two substances. What are they? Liquid water, I'll write water and steam. Water and gas, which is steam. Okay, so there is potential energy is changing because of what? There is a phase change from what to what? Liquid to gas, which is called vaporization or boiling. And what is constant there? Temperature is constant. Then line E. There is only one state of matter, which is what? Steam. And steam's temperature is increasing. That means there is a change in what? Kinetic energy, yes. And change in temperature also. Increase in temperature. It will keep on increasing because we are not talking about the last state of the matter here. We can't achieve that here. Question about that. Good? Good. Those are the basic information. Now we are going to apply that here. Yeah. Heating curve calculation. It's very easy. See, just focus and understand. This one is very easy because all the formulas you already know. You know how to calculate. We already learned everything. Just to scaffolding the question, that is the only problem. Okay. So we can see energy content of water is changing while you are heating or looking at the heating curve. So if you have all the right information, we can calculate how much amount of energy is being absorbed or released. If you are going towards the right, it is absorbing endo. If we are going towards the left, it is releasing, which is exo. Okay. I'm going to do, like we will split that into two. First, we will do only the slanted line. Okay. Like we are going to do calculation from this slanted line. When the temperature is changing, we know how to calculate Q. What is the equation for Q if temperature is changing? Q is equal to, there is only one equation. Yeah. Q is equal to M cat. M times C times delta T. So all slanted line there is temperature changes. So you are using this equation for all this line if you have a question from that line. So you have to understand whether it is that line or this line based on the question. Okay, look at this. For example, let's calculate Q from which section? C. If you are starting with the 25, I'm going to write 25.0 gram because I don't want anyone rounding the answer to 2 sig figs. Keep it 3 sig fig. 25.0 gram of water. Okay, section C. look at this. Section C is starting from here. What is the starting temperature? 0. And what is the final temperature? 100. So we are going to substitute that. Q is equal to mass. Mass is 25.0 gram. And it is water, and make sure you are picking the correct specific heat. There are 3 specific heat you can see on your formula sheet. 1 for water, 1 for ice, 1 for steam. This is water, so we are going to pick what? 4.18 joule per gram degree Celsius. And change in temperature, it is the difference between 100 minus 0, which is what? 100 degrees Celsius. Just add a decimal there. I don't want anyone round your answer to 1 sig. Okay. And the final answer is 10,450, or I will write what? 10,500. So that is the answer for heating water from 0 degrees Celsius to 100 degrees Celsius. You have to supply this much energy. Do you all understand how to do it? Okay, now do that for section E. And assume the temperature mass is same. I would say 25.0 gram. Section E is here. The starting temperature is what? 100 degree, and on your graph it is 137 is the final. So go to calculate that. Yeah. So keep the sig fig 3. Q equal to M times C times delta T. There is a problem. Did you notice that problem? Specific heat you have to use for what? Steam, gas. Look at the formula sheet and find the value. What is it? 2.08. That is a place. Most of the time people will make mistake. Avoid that, okay? So 37.0 degrees Celsius. Okay, now multiply and calculate. 1920 joules. Are you all good with that? Okay. So now go to the next page. So we already learned how to find the values on the slanted line. Now I'm going to teach you. Who has question? Any question? No? My iPad will die now. Hey, look at this. Second part of this. For section where temperature is constant, we cannot use the MCAT, right? Where heat change is occurring, but we can't use this equation. Why? Because delta T is equal to 0, then you will get answer 0, right? If you use that equation. You will get Q is equal to 0, but that is not 0. Oh, sorry, that is not correct. So we have to look for other solutions, right? So we are going to calculate the energy change in line B and line D. Okay, so we are calculating in joule per gram. That's why I crossed that 2 units. Okay, so your formula also I'm going to change it. energy is still being absorbed, we know that we are heating, we are providing heat, or if it is releasing, if we are cooling. So I'm going to use the equation, just take the molar mass away. So the equation is, if you want to write one more time, mass times delta H of fusion. So where delta H is the enthalpy change for fusion. If it is ice, the value is 334 joule per gram. Again, it is on your formula sheet. Okay. That is when fusion means what? One more time, fusion means what to what? Yeah, it is a interchange between solid to solid to liquid. That is called fusion. Melting, freezing, all other terminology you can use. Okay, then second one, again, I'm gonna cross the molar mass. We don't need to do that in moles. So the equation is mass times enthalpy change of vaporization, where delta H of VAP is enthalpy change of vaporization, enthalpy change of vaporization, and has a value, it is given in on your formula sheet, which is 2260 joule per gram. Okay, now let's try this equation. So here, section B, we are going to write on this equation. So section B is solid to liquid. So you are going to use delta H of fusion here. And section D is liquid to gas. So mass times delta H of vaporization here. If you want to write that like a solid liquid, you can. Okay, so let's do this. We are going to calculate for section B. Section B, we know that what is happening there. Ice is converting into what? Water, and that is called what? Fusion. So then write the equation Q is equal to mass times delta H of fusion. Mass is 25 gram times fusion is 334 joule per gram. Then multiply. 1,800 or 920. I don't know. Multiply. Get your calculator and do it. Oh, my bad. Okay, 8,350. You want to understand this? Okay, so now I'm going to give you the practice. There will be question on your test. Maybe I will give you ice. Then you will do A, B, C, D by step, and you have to find how much energy needed to reach steam, something like that. So let's go practice now. If you want to write again the equation, this is already we wrote, okay? If you want to write it again, that's up to you. Like a straight line, we are using this equation. Slanted line, we are using this equation, okay? Okay, go ahead and do question number 1. That is very easy. We'll check the answers after a few seconds. Let me go find the... Yeah. So do this one. Question number 1 on this, below this. What is the change in heat on section C? It's the same thing. We already did that.
Can I go to the bathroom?
Let me go find the charger for this. If you are all good, we can skip those questions and go to the difficult one. You need to do the easy one or difficult one?
Will the difficult one be on my test?
Yeah, that is only one on the test.
Oh, wow. So there's no easy ones on our test?
No easy ones. Because you will get only one question on your test from this. Like calculation, one question. Conceptual also there is 2 questions, I believe. I don't remember. Okay, I'm gonna do question number like this one, and then rest of the time you are going to do the practice, then I'll come around and help you guys, okay? Let's do this together. Okay, see, understanding the question is the difficult part here. No one there will be to scaffold this for you, okay? So you guys need to read it. It says you are going to find the Q. You are finding from where? Section A, end of section B, using how much gram? 30 gram of water. Can you do it? Is it difficult or easy? So section A, so I'm going to write section A. That is Q1, right? Which equation you will use on the line A? M times? Yeah, M cat. Because it's a slanted line, right? Yep. So M is 30 gram. Just put a decimal there. Don't want anyone round that to 30 gram. And C for ice. Line A is ice. So ice has a value what? 2.1 joule per gram degree Celsius. And change in temperature, we are starting from negative 46 to 0. What is the temperature then? 46. So calculate that. Then go to line B, where is Q2, there is a melting. So you will write M times delta H of vaporization. Same mass, we started with the 30 gram, times vaporization is 334 joules. Then we need to find the total energy, so you will add what with what? Q1 plus Q2. Yeah, it's fusion, my bad. I put the correct value, though, It's fusion, not vaporization, my bad. Okay, so now what is the answer? What is the final answer? Or what is Q1 and Q2? 840 total energy. You all agree with that? Okay, so that's it. Yes. Someone is out, right? You have to wait. Okay, now do these questions. So you have to change some of the value. Here this is 334. There is a typo there. You have to write 334 there, not 344. And then rest is all yours. Go do it. Yeah, 3. Yeah, sig fig. Whatever is the lowest amount.
Otherwise, if we're 6x for final.
That's maybe by adding, right? What is the first answer you got? 2910. Okay. 2910 will be 2900 joules because 2 sig fig, right?
No, I already.
Now, what is the first one?
The first one I got was 2911.8.
Okay, that is 2900, right?
And we're basically.
What is the second one? What is the value for Q2 is? 10? Can someone tell me that? What is Q2 is?
That's 10,020.
10,020?
Yeah.
That means that is 10,000, right?
Oh yeah.
Then how come you got 15,840 while adding it?
I didn't use the sig figs.
You had to use the sig fig, okay? So 10,000, let me correct that. So that will be 10,000 plus 2,900. That is it. That is addition, so 12900. That is the answer.